In this lesson today, we are going to talk about prisms, and we're going to talk about the surface area of prisms. So the first thing we need to know is, what is a prism? Well, if you draw a polygon, so an n-sided shape on a piece of paper, then you extend all of the edges perpendicular to that base, and then you cut off and get the identical shape on either end. We've created a prism. So it is an infinite number of layers of that particular shape. A prism is a polyhedron, which means all faces are flat. So you can see that all faces are flat. That creates a polyhedron, which is one of the polyhedrons is a prism. A polyhedron that is not a prism would be a pyramid. So I could start with a shape, but instead of perpendicular, they all meet at a vertex. That is a polyhedron, but it is not a prism. Okay? A cylinder looks like a prism because you start with a circle, extend up, and cut off. So it has the same characteristics as a prism, but curved surfaces are not considered polyhedrons, so it is not a prism. So we have a triangular-based prism, a trapezoidal-based prism. You can have a square-based prism, a rectangular-based prism. You could have a hexagonal-based prism. You could go on and on and on. Okay, so as long as you start with a polygon. So if we wanted to find the surface area of a prism, we want to find the sum of every face of the prism and just add them up, right? So that's the sum. Just find the area of every face and then add them all up. So we are going to need to find areas of triangles, rectangles, parallelograms, trapezoids, hexagons, etc. So let's practice calculating our areas of those particular shapes. So rectangles and parallelograms. A rectangle is basically your length times your width, or your base times your height, whatever you want to call it. I have 3 layers of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 3 layers of 10, so it's 3 times 10, which is 30. A parallelogram, if I was to cut off this part of my parallelogram and stack it over there and move it over there, it's basically a rectangle as well. So instead of doing that every time, I can just say, okay, well, it's going to be base multiplied by my height, but my height extends from the base, from between the 2 parallel lines. So my height doesn't fall. It's not the slanted side. My height is always perpendicular to my base. So my base is going to be 1, 2, 3, 4, 5. And my height is going to be 1, 2, 3, 4. So my area in this case is 5 times 4, which equals 20 square units. This would be 30 square units. It's how many square units cover the surface. A triangle is basically half a rectangle, isn't it? It's base times height, but you only want half of it. So my triangle is going to be base times height divided by 2. And again, my height is always perpendicular to my base. So if my sides of my triangle are not perpendicular to my base, I do not have a right angle in it, my height, again, just like the parallelogram, extends from the vertice perpendicular to the base, whichever base you choose. Okay, so base, the whole base, multiplied by the height, divided by 2. Same thing here. If I choose this to be the base, my height has to be perpendicular, so I have to extend my base to create my perpendicular height. I could have chosen this to be my base and this to be my height as well. There's 3 choices for it. But however it's labeled, you might have to use the numbers given to you. What about a trapezoid? Trapezoid has 1 set of parallel lines. The other lines are not parallel. So those 2 lines are parallel. So to find the area of a trapezoid, again, if you take a look at this, if I cut this off and I move it over there, hey, look, it's just a rectangle. but they're not. It's not always what I call an isosceles trapezoid, where those two sides are the same. They don't necessarily have to be, so it doesn't always work like that. So here's the best way to do it. Well, I take these two parallel sides, the sides that are parallel, let's call them A and B, like 6 and 10, for example, and then you take the average of the two, because if you take the average, this extends, and this one shortens out to be the average of the two. How do you find the average of the two? You add them up and divide by 2. So you take the average of your parallel lines, and then you multiply by the height. And you multiply by the height of the trapezoid. And that'll give you the area of a trapezoid. Here's a hexagon. I call this a regular hexagon. Regular hexagon means that all sides are the same. So those are all identical. Okay, so if I know, let's say each side is 5, it's a regular hexagon side 5, then I can find the area of a hexagon by finding the area of one of the triangles. I just need to know the height of this triangle, okay? Which, if I knew the distance all the way across, would be half of that, right? So if all the way across through there was, let's say, 12, then my height would be 6, right? And there's lots of different formulas you can use. This is just a basic one. So I would find the area of one triangle, which would be base times height, 5 times 6 divided by 2, which would give me 15, and then you just multiply by how many triangles there are. Right? Oh, there's 6 triangles. And that's how you would find the area of a hexagon, if it's regular, if all of the sides are the same. Let's take a look at this question. How does the area of triangle AEB compare to the area of the parallelogram ADCB? I don't even need to calculate the areas. I can just notice that the area of the triangle is going to be base multiplied by the height divided by 2. And I know the parallelogram is going to be base, which is AB, multiplied by the height, which is the same for both, but I'm not dividing by 2. So the triangle will be half the area as the parallelogram, or the parallelogram will be twice the area as a triangle. If I didn't give you the grid marks, you should still be able to answer that, knowing that since EC is parallel to AB line, that they have the same height. All right, let's get into the surface area now. I have 3 questions. We'll start with a rectangular based prism. So when you have a rectangular based prism, there's lots of options for the base. I could make this the base, which the opposite side would be this. Yes, that works out. Or I could have stood it on its end like this, and I could have made this the base and that the top. So you can rotate that any which way, and you still have a prism with different bases. It doesn't really matter. Base is not necessarily what it's sitting on. The base is what creates the prism. So if it extends vertically, perpendicular to the base, do I have the same shape on top? Okay, so let's find the surface area. Well, there are 6 faces. Does everyone see the 6 faces? The 2 sides, the top, the bottom, and the front and the back. So since they all come in pairs, I'm just going to find the area of one of the faces. Let's say I find the area of this side right here, which is 3.2 by 5, right? The 5 is over here, but we know that all the verticals are 5, so it's 3.2 multiplied by 5, but I'm just going to double that. And so the 2 sides are going to be 32 square centimeters. Now let's do the bottom and the top. The bottom is 11.5 by 3.2. And again, I'm going to double it because the top is the same. And you can just keep yourself organized on the side this way. And I get 73.6 square centimeters. And the only one I haven't done yet would be the front and the back. So the front would be this right here, which would going to be 11.5 by 5. And the back is the same, so let's just double it. And I get 115 centimeters squared, and then you just find the total sum of those 6 faces, which those are 3 pairs. So I get the total sum, which will be 115 plus 73.6 plus 32, which gets me 220.6 square centimeters. The little power of 2 on the centimeters is not on the number. There's 200, and this just means there's 220 and almost another whole one, a little over half of these. 1 centimeter by 1 centimeter is equal to 1 centimeter squared. So the little power of 2 just means we're talking 2 dimensions. That's all that little power of 2 on the square centimeters means. All right, let's try another one. This is a triangular based prism. Most people make their mistake by telling me this is the base. It is not the base, because if I extend all sides perpendicular to that base, I do not get a triangular based prism, and it is not a prism that way. The base is the side that you would be sitting on, the triangle, and then you extend all the sides up, and that is going to create your triangular based prism. So the triangle is your base. We don't really need to know what the base is right now, but for naming it, that's why it's called a triangular based prism. It'll help us with volume, knowing which one's the base later. But what we do need to know is the area, the surface area of the shape. So in this triangle, I can see, triangular based prism, I can see 2 triangles plus 3 rectangles. Are the 2 triangles the same? The front triangle and the back triangle? Yes, they're identical. So I can just find 1 triangle and double it. Are all the 3 rectangles the same? This is 2.5 by something. I actually don't know what that is. I'm going to have to figure that out. So that one, this is 7 by 2.5, and this is 8 by 2.5. So all my 3 rectangles are all different. So I'm going to have to treat those separately. If your triangle is scalene, all 3 rectangles are going to be different. If your triangle is isosceles, 2 of the rectangles are going to be the same. If your triangle is equilateral, all 3 rectangles are the same. It'll give you a shortcut. So let's start off with our triangle in the front. Well, the area of the triangle is going to be base multiplied by height, right? Or this base is 7 multiplied by the height, which is 8, divided by 2. But there's 2 of those triangles, so now I'm going to double it. And what we'll see is that those doubling and dividing by 2 actually cancel each other out, so I can just say it's 56. Now I'm going to add on my 3 rectangles. I can see the bottom rectangle is going to be 7 by 2.5. I'm going to add on the side triangle, which is going to be 8 by 2.5, because that's also 2.5. And now I'm going to add on this diagonal rectangle, the one on the side right there, which is going to be, sorry, get my pen, there we go. It's going to be, I don't know, by 2.5. So I don't know this side here. Well, this length here is the same as this length right here, and if I look at the front, it is a right triangle. So that's not a right triangle. It is a right triangle, 7, 8, and I don't know. So we can use our Pythagorean theorem. C squared equals 8 squared plus 7 squared. C equals the square root of that sum, so the square root of that sum is 10.6. So now I know this length is 10.6. Now I can plug that in. And now I can calculate this. So I get 7 by 2.5 is going to be 17.5. I get 8 by 2.5 is going to be 20. And I get 10.6 by 2.5 which is going to be 26.5. Now I can add that all together. And I get 120, once I add that all together, 120 square, oops, this is in meters, square meters. So I put the little power of 2 on the meters to say there's 120 square meters. All right, we'll try one last one together. So in this one, it is an isosceles triangle as the base. Because there's two little lines there, you see those two little lines? Those lines mean that those two sides are the same. And since I have this labeled as 5 there, I know that this side is 5, and so is this side. So it's an isosceles triangle that is 5 by 5 by 6. And so here we have again 2 triangles plus 3 rectangles. And in this question, 2 of my rectangles are identical, right? We have the 8 by the 5. Right? Oops, that looks kind of funny. I should redraw it so it looks like that. I have the 8 by the 5. So I can go 8 by 5 and double that. 2 of my rectangles are complete. The bottom rectangle, the floor of my prism here, it's not the base of my prism, it's the floor when it's sitting like this as a tent-like shape, is 6 by 8. And so it's just the 2 triangles I need. So my triangle, the area of my triangle is going to be base times height divided by 2. But in this question, I don't know my height of this triangle. So that's what I have to figure out. So how can I figure out the height of this triangle? So just looking at the triangle here, how can I find the height? Well, since it's isosceles, and these are both 5, and the bottom is 6, if I cut an isosceles triangle exactly in half, I get 2 identical right triangles. Since the whole bottom is 6, I can say each side is 3. So I can now find the height using a right triangle or the Pythagorean theorem again. So I can say, oh, this time I can say h squared equals 5, which is the hypotenuse, 5 squared minus 3 squared. And then I can calculate that, oh, h is the square root of 5 squared minus 3 squared, or I can recognize one of our very common Pythagorean triples and say h is 4, 3, 4, 5. And so now I know the height of that triangle, and so now I can go ahead and calculate it as the base of the triangle. Don't use 3 now, I just used 3 in the Pythagorean theorem. The base of the triangle is actually 6. I'm going to go 6 by 4 divided by 2 and doubled. Just again, remember when you're dividing by 2 and doubling, they cancel each other out. So you're going to get 24 plus 40 doubled plus 48. So all together you're going to get 152 square meters. So you can practice on the homework assignment calculating surface area of different shapes. I've created a worksheet. If there are some typos, please email me and I will fix them up and repost.